Coroutines. What are those? How to start them, how to stop them, and more in this video. I'll start with the theory, so if you're interested only in certain part of the video, feel free to jump to the appropriate timestamp, and all the timestamp you can find them down in the description. What are coroutines? So I put together a definition that might sound a little bit scary, but bear with me. Coroutines are Unity objects that use IEnumerator for splitting action over multiple frames. Coroutines are basically functions that return IEnumerator. Important to mention, coroutine system is Unity specific, so if you want to start a coroutine, you need to inherit from monobehavior. Whereas IEnumerator is C# thing because it's part of .NET. It is used for iterating through collections and arrays, and the most important thing is that it remembers its current state. That's why coroutines can stop its functionality and return back where it left off after yield return. I will show you a little demonstration. So I have two squares, one start, one end. The start one has a script called coroutine script. For comparison, I have a function called moveToFunction and moveToCoroutine. Both of them do exactly the same. They are moving the first square to the second square using transform.position. So I'm gonna first call the move function at the start, and let's look how that looks like. If I press play, the square gets instantly teleported to the second square. That's because when you're doing a while loop in a function that is called once, it's gonna be done in one frame. So if we try to do that in our coroutine instead of our function, the result is totally different because each transform position is executed in a different frame. So why would you use a coroutine? If you want to split an action over multiple frames, you can do that using multiple bool values and multiple conditions, but that would get pretty complicated pretty fast. Or you can use coroutines that are able to pause for a couple of frames/seconds and then get back where they left off. When you're using coroutines, the code is much more readable and it's much more efficient because you don't have to use conditions that might not be relevant at the time being. When to use coroutines? When you want to pause something for a period of time. For example, if I step on a trap, there might be a cooldown, and after the cooldown something else happens. Let's say spikes started falling on me. When you have a code that needs to be executed over multiple frames instead of one frame. For example, if I have 10 numbers and I want them to be printed, I can use a loop with a yield return, which will wait to another frame, and each number would be printed in a different frame. Or when you want to execute a sequence of actions. For example, when I open a chest, I can play an animation of opening chest. After a couple seconds, there might be another action of some kind of reward being picked up. And after that, there might be a closing action or some kind of closing animation for a chest. So sequence of 3 possible events taking place after each other. How to create a coroutine. As I said before, coroutines are super similar to functions. You just slap an IEnumerator as a return value, which also means that you're gonna have to return something using a yield keyword. You can choose from a list of predefined yield instructions. Each yield will pause accordingly to the instruction you return. In this example, I'm simply just returning a null, which means that it's gonna return to the next frame. If I printed something here and printed something there, something would be printed, and since returning null returns to the other frame, something else would be printed in the following frame. There are a total of 6 instructions that you can choose from. Wait for seconds real time, wait for end of the frame, wait for fixed update, and wait until, and wait while. Probably the most used is the first one, wait for seconds, which takes one argument, which is time in seconds. It is similar to the second one, which is not affected by timescale. So if I used coroutine with both of those statements, wait for seconds and wait for seconds real time, one would be affected by timescale. If I changed timescale like I'm doing it now in my start method, I'm setting timescale to 0, so everything should be stopped, and wait for second would be stopped also. But the second one wouldn't be affected and would continue with the time that you passed in. Next, we have wait for end of frame, which is similar to returning just now, as we did before, but there's a slight difference. One returns just before rendering, and the other returns just after. So the wait for end of the frame returns here, and if we used a null, we would return here. On the same note, we have wait for fixed update, and as you probably know, fixed update is not synchronized with normal update. So if you want to wait for a physics update, which is usually done in the fixed update, you can use this instruction. Last two instructions are wait until and wait while. They both need a delegate that is type of bool or it is a returning bool. And as you can see, I have a simple function that is returning bool. It's called delegate bool and it's simply returning true. And the difference between wait until and wait while is that wait until suspends the coroutine execution until the supplied delegate evaluates to true. And since our delegate is returning true, this instruction would pass, but wait while wouldn't pass because we are returning true. We would have to return false. The delegate can be more complicated. You can have whatever condition here, and as long as your delegate is returning boolean value, which is false and true, you can pass it to the wait until and wait while. When I was first testing it, I put my braces there and I was super confused why I had the squiggly line. So after a couple of minutes, I realized that there's no need for that. So don't make the same mistake as I did. How to start and stop a coroutine. So now we know how to create coroutine, how coroutines work, what instructions you can use, but we still need to know how to start coroutines. There is a function called StartCoroutine, which is part of monobehavior, and if you look at the definition, as you can see, there are two possible options that we can use. I would start with the second one, which takes IEnumerator as a parameter. So we have our StartCoroutine in our start method, and we can pass the name of our IEnumerator, which is name of coroutine. So like this, we would start our coroutine. This is the simplest way of starting coroutine. I'm just gonna change the 1 to 4 so we can see the change happening. If I press start, we should see one message, and after 4 seconds there should be a pop-up for another message. So it's working as I would expect. There is one downside to this approach, and that is that we cannot stop this coroutine. We just started the coroutine with this name, but we don't have the reference to this coroutine. We can use stop all coroutines, which would stop all coroutines on this script, but if we had more than one and wanted to stop only this coroutine, we wouldn't have the way to do that. Next option to start a coroutine is to use coroutine keyword. We can create a value that is type of coroutine, and in our start method we can say that core is equal to StartCoroutine, and we can specify the name of the coroutine, and this line of code will already start the coroutine, and we're gonna have a reference to the coroutine that we started. Since we have a reference to our coroutine, we can also stop the coroutine. I'm gonna test it first. We should get the same result as before. So we should have something printed, and after 4 seconds there should be something else. So that's the same functionality as before. If we want to stop the coroutine, let's say I want to start the coroutine only if I'm pressing some button. And if I press a different button, I'm gonna be stopping the coroutine. When you want to stop coroutine, you're gonna be using StartCoroutine function, which takes one argument, which can be either coroutine type value or IEnumerator. In our case, we are passing our core, which is a coroutine type, and we are saying that when we press F, the coroutine should be started. But this code is in a start method. I'm gonna move it to our update. I'll put a higher number than 4, for example 10, so we can have more time. Now, if I press S, we should see something. And after 10 seconds, it should stop. But if I press F, which I did, there is not gonna be end of our coroutine because we stopped it. And if I press S again, the coroutine will start again. And after 10 seconds, it will print the end of the coroutine. Okay, so the coroutine ended. So as you could see, when we are using the coroutine type value for starting our coroutine, we can stop it because we have a reference to it. But when we stop it and start it again, we cannot resume where we ended before because we are pretty much overriding a new coroutine with our code. Next version of starting a coroutine is to use string. So if we say StartCoroutine, and as a parameter, we pass the name of our coroutine, which is name of coroutine. We should be able to start it, and we also can stop it as before. When we are stopping the coroutine using string, we are using also the name of the coroutine. So if we try it, we should have the same result as before. If I press S, the coroutine started. If I press F, we should have stopped the coroutine. So if I try to wait a little bit, we should not see the end of the coroutine. So that's working. And if I press it again, the coroutine starts again. And after a couple of seconds, there should be end of the coroutine since I'm not pressing anything. Okay. So, using string is pretty much the same behavior as before. We can start the coroutine using the name in a string, and we can stop the coroutine using its name as a string, as a parameter. I would avoid using this method because if I add, let's say, next E to our coroutine and save it, there are no errors. Everything is perfectly valid. But if I try to start it now, we should see some errors pop. So if I press S, you can see that there is an error. Couldn't be started because we named it incorrectly. So I would avoid using this method since anybody in your project can rename your coroutine, and you can happily use strings or the old strings that you've been using before, and if nobody warns you, your code isn't working anymore. And the last and probably the best option of starting a coroutine is to use IEnumerator variable. So let us create variable type of IEnumerator. And in our start, we're gonna say that our variable core is, and we're gonna pass our IEnumerator, name of the coroutine. So now, in our IEnumerator, we have a reference to our coroutine, and we can just say StartCoroutine, and we can pass the name of our variable, which is core, like this. And in the same manner, we can stop the coroutine using the core variable. And the difference between this option and using the coroutine keyword is that we can resume where we ended, because we are not starting a new coroutine, we are starting the same coroutine that we have reference for. Let's see how that works. So if I press S, the coroutine starts, and if I press F, we pause the coroutine, so it's not gonna print something else in the end of the coroutine. And as I press S again, the coroutine will end, because it's not gonna return to the remaining time in our wait for seconds. It will return to the code after that. So immediately when I press F again, something else is gonna be printed. So let's try that. I'm gonna press start again now, and immediately something else was printed. So let's add more yield statements. So when we start the coroutine, we're gonna say something. It will wait for 10 seconds and we can pause it using our stop coroutine. And when we start the coroutine again, we should start with this code, so it's gonna print something else, and it's gonna wait 1 second, and after 1 second it's gonna print end of the coroutine. So let's try that. So if I press S, our coroutine started. I can stop it by pressing F, so I stopped it now. And if I press S again, we should see something else, and after 1 second, end of the coroutine. Using this method, and by this method I mean IEnumerator core variable, we can start the coroutine using the variable that we created, and we can also stop the coroutine using the variable that we created. The plus side of using this method is that we can resume where we ended, but you need to keep in mind that when you stop the coroutine, we stopped it in this period of time, and started again, it resumed after the first yield return. So you need to keep that in mind. Also, important thing to mention, and that counts even for the examples before, if you have a reference to a coroutine, you need to check if it's not null, because if I comment this piece of code and start the coroutine without having a reference, or even stop the coroutine without having a reference, there's gonna be some errors thrown at me. So if I try to stop the coroutine even without starting, so I'm gonna stop, and as you can see, the routine is null, error. Even if I try to start the coroutine, there's gonna be another error because I don't have the reference. So when you're starting and stopping the coroutine, you should first check if the variable that you're using, the IEnumerator core variable, if it's not null, and if it's not, you can start it and stop it whenever you want. Before I end the video, I have 2 more tips to tell you. The first sneaky tip that I have for you is that you can start a second coroutine inside another coroutine. So we have our first coroutine, that is name of coroutine. We print that the first coroutine started, and in our yield return, we are starting a coroutine and we are passing the second coroutine that we created. And the second coroutine, it just prints that the second coroutine started, it waits 3 seconds, and at the end it prints inside coroutine ended. So when we press S, the first coroutine starts, the second coroutine starts immediately because we yield returned immediately, and after 3 seconds the inside coroutine ended, and the last debug log has been printed from the first coroutine. And the second sneaky tip is that you can change the void in a start method to IEnumerator. This way you convert the start method to a coroutine, so there needs to be a yield return. And this way I can delay the initialization by 4 seconds. I can put a debug here. I have no idea how to spell initialization, but let's try that anyways. So we started the program, and after 4 seconds there should be delayed initialization, so it works. And I wouldn't use it for anything else than just delaying something in the start. If you want to do something more complex, you can start the coroutine from the start method. Okay, I think that's all from me. I hope you enjoyed it. If you did, you can press the like button. Or if you didn't like it, you can write me a comment with a constructive criticism, what I can do better in future. Speaking of future, if you want to see more videos from me, you can press the subscribe or even click the bell on the right so you get notified when I create a new video. And that's gonna be all from me. I'm gonna see you next time. Bye!